Good evening. This is Mayank Sharma, 19 BC 1145, giving my digital assignment 3 on the topic ElGamal Cryptosystem for the course Blockchain and Cryptocurrency Technologies, CSE 1006. Cryptography in blockchain. Blockchain is a peer to peer network. The word blockchain itself is made up of words block and chain. Block is referred to as the collection of data, and chain is referred to the public database of these blocks, which is stored as a list. These links are connected using cryptography. This makes cryptography the most essential and fundamental concept for creating a blockchain. So, uh, ElGamal cryptography uh, will is also used as a way to join this link, which is very essential in a blockchain system. So cryptography is basically method of developing techniques and protocols to prevent a third party from accessing and gaining knowledge of the data from private messages during a communication process, or maybe without that. But the basic idea is a third party should not get any access to the data. The word cryptography is made up of two ancient Greek terms, cryptos, meaning hidden, and graphene, meaning to write. So, some terminologies we need to know before further going are encryption, the process of plain text to a ciphertext, a random sequence of bits, so that if we want to hide the plain text, which is sometimes confidential, so it is converted to a ciphertext for hiding. And key, which is a small amount of information required to induce the output of the algorithm, the cryptographic algorithm. And decryption is the it's basically the opposite of encryption, at the name suggests, the inverse process of encryption, conversion of ciphertext to plain text. And cipher is the mathematical function, a cryptographic algorithm which is used to convert uh, which is used in the process of encryption from plain text to ciphertext. So yeah, types of cryptography. There are mainly three types: hash functions, symmetric, and asymmetric key cryptography. We'll see one by one. So, hash function. It does not. It is the only type of the three which doesn't use any keys. It only uses a cipher to generate a hash value of fixed length from the plain text without using keys. It is nearly impossible for the contents of plain text to be recovered from the ciphertext. So, the main functionality of using hash function is this only, that the conversion is nearly impossible from plain text to ciphertext. Symmetric key cryptography. In this encryption method, we take a single key into application. Hash function didn't have any key, and symmetric will have one key for the encryption process. This common key is used both for the encryption as well as decryption also. As we saw, that decryption is also necessary to in the cases we need to know the original plain text from the ciphertext. So that only that one key will be used for both the processes, encryption and decryption. And using a common single key creates problem of securely transferring also between the sender and receiver. This process is called secret key cryptography. Then comes the last one, the asymmetric key cryptography. This encryption method uses a pair of keys, an encryption key and a decryption key, named public key and private key respectively. The key pair generated by this algorithm consists of a private key and a unique public key that is generated using the same algorithm. And this one is also known as public key cryptography. So the pair generated in this algorithm, the in this cryptography technique, the private and public pair, are used for encryption and decryption. The private key is always with the original maker of the text, and the public key is used by others to receive text and similar things. Okay, so the ElGamal crypto system is a type of public key crypto system, which is this one only, asymmetric key cryptography. It u- uh, it uses the cryptography for communicating between two parties and encrypting the message. This system, based on difficulty of finding discrete logarithm in a cyclic group that is even, if we know GA and GK, it is extremely difficult to compute GAK. Like, if we even know both the keys, it is difficult to decrypt the messages. So in this ElGamal crypto system, total two keys are used, one for encryption and decryption we discussed, and the following three steps are followed. First is key generation, second is encryption, and third one is decryption. So in the key generation, uh, a large prime number P is selected, then a decryption key or a private key D is selected, then a second part of the encryption key or public key is selected, then calculation is done for the third part of the encryption key, and the public key formula is given by E1, comma E2, comma P, where private key is D, and then respectively the encryption and decryption follows. So the basic idea behind this ElGamal crypto system can be explained in the following three steps. Suppose a person Elias wants to communicate with Bob. So first step will be Bob generates public and private keys. Bob chooses a very large number Q and a cyclic group FQ. From the cyclic group, which was selected in the previous step, he chose any element G and an element such that GCD of A and Q is 1. The greatest common divisor of A and Q is 1 only. Then he computes H, which is G into A. Simple formula is there. And after that, Bob publishes F, and H is equals to GA, Q and G as his public key, and retains A as private key. The second step is Elise encrypts data using Bob's public key. So she basically selects an element K from cyclic group F such that the greatest common divisor of both of them, K and Q, is 1. Then she computes PS, P and S by the following formulas: G into K and H into K, which is also GAK, we may say. Uh, Both of them will be equal only. She multiplies S with M. Then she sends uh, the pair P comma M into S, or we can say GK comma M into S. The third step is Bob decrypts the message. Bob calculates S dash is equals to PA or GAK, then divides M into S by S dash to obtain the M, the plain text, the original message. Uh, in this crypto system, the original message M is masked by multiplying GAK to it. To remove the mask, as we saw, a clue is given in form of GK. Unless someone knows A, he will not be able to retrieve M. This is because finding discrete log in a cyclic group is difficult, and simplifying knowing GA and GK is not good enough to compute GAK. So, as we discussed in earlier slides, this is the main advantage of using ElGamal crypto system. As we can see, knowing both the keys also doesn't help you to know the plain text or the original files which are hidden from you. So if we talk about security and algorithm, The security scheme depends on the properties of the underlying group G as well as any padding scheme used on the messages. If the computational CDH, the Diffie-Hellman assumption, holds in the underlying cyclic group G, then the encryption function is one way. ElGamal is unconditionally malleable and therefore is not secure under chosen ciphertext attack. This can be explained by the example given an encryption C1 comma C2 of some possibly unknown message M. One can easily construct a valid encryption C1 comma 2C2 of the message 2M. So, like we were discussing that knowing both the keys, we cannot decrypt the messages. But yeah, for 2M, it can be done, and further, the M message can be leaked. And if we talk about the efficiency, ElGamal is probabilistic, meaning that a single plain text can be encrypted to many possible ciphertexts, with the consequence that a general ElGamal encryption produces 1:2 expansion in size from plain text to ciphertext. So this is one more characteristic feature of ElGamal, that it can be used to convert the message into many possible ciphertexts. And encryption under ElGamal requires two exponentiations. However, these are independent of the message and can be computed ahead of time if needed. Decryption requires one exponentiation and one computation of a group inverse, which can, however, be easily combined into just one exponentiation. So, this was the idea of ElGamal cryptocurrency, which uses the asymmetric key cryptocurrency system. So, yeah, thank you.